Hello everyone. Today we will look into noms, the package Nutrient Object Management System, and this is an introduction to how to use the package. It is available through the pip installation, the utility, but the thing is, it is the package when you install through that, it is not working. The person who has wrote it, Noah, he hasn't been working on that, and they changed the API and the package is not working. So what I have forked the package, and this is a link that you see here. So you could download it. You download the package and put it in the working directory, and then you can use it as a regular any other package. So what I'm going to do is, for example, we can just git clone, and we pass the package, copy this link, and then so the package basically helps you to look at, you can use the United States Agricultural Department, the database. It's an API, so it gives an easy access to the API, and you can download the nutrition data in the different foods. So let us say, first of all, we import noms, and then we can just, first of all, you need to get a key. It is already in the how to get the key. So you can go to this place and sign up for this is very easy step. You fill in your details, and you can sign up for an API key. You can download, can create a key, and then it's a long string. You can write it into a file, and then you can just read it back from the file. For example, I can say key equal to open my API key dot text, and then we say in a read mode dot read, and so that saves the key in the variable key. Now we can go ahead and use noms and initialize the client. So the client equal to noms dot client, and we have to pass in the key. So the key is key. So now let's just run that and see. Yeah, so it works. So we have initialized the client object with the key. So now we can start searching for the food. Results equal to client.search query, and we pass in, say, raw broccoli, and then say print results. So now it gives me a list, and it returns. So we have we get the IDs, the FDC, the FoodData Central, the IDs corresponding to each. We need this, and we can save. So they have different sections, and so we take the, say, broccoli raw. We'll take that one. This is 74747. So what we are going to do is, for example, we are going to collect the data corresponding to the food that we are having a particular day, and we can look at it is deficient in the particular nutrient, or it has all the nutrients. So let's say we create a food list, maybe food bit, maybe daily. I have here a list of different foods that I collected. 100 representing in grams, 100 grams. So now, ideally, we can rewrite this dictionary, food dict daily. For example, if you take ripe plantain, what you may need is I ate 1 plantain. So I may need to find out how much how much weigh 1 plantain. So you can have a conversion factor and convert into grams. And for example, plantain, it is about, in a medium-sized ripe raw plantain is about 180 grams. So you can go on preparing a list and add how much you had particular food in a particular day, and check if the RDA's recommended daily allowance is met. So I'm gonna go ahead and do that. I have already prepared a list, so I have rewritten the list in such a way that each of these corresponded to how much food that I had. My 2 bananas or 2 plantains, 2 tablespoons of sugar, and so on. So now what we are going to do is we have to in noms we can prepare the food objects just by, so we can get the food objects by passing this dictionary to, we say, food dictionary daily. So this dictionary passes this, and it will get, if you run this code, it is going to generate, it is going to keep on going through this each items and download the corresponding data from the database, United States Agriculture Department, USDA website. They will go there, it will go there and grab all the results for us. And then it will say create the food object, which will have as its attributes the nutrients and other information. So you could run this. I have already saved it as a pickle, so I can, rather than to save time, so I'll say import pickle, and then I can just load those data. To do further analysis, we have to create a meal object. So noms dot meal, and you say food obj. So we create a meal object from there, and once you have the meal, we can create a report, and we can create a report out of that. We will say R equal to noms dot report, and we pass in the meal. Now I can look at for I in R. I in R, we can say print I of name, which is a nutrient name, comma, maybe a tab, I of the RDA, the required value, and we could say tab. We also say I of value, what is the value that we are having. I mean, how much we consumed. This was supposed to be I. So you could see each of the items, the deficient. And then now let us print this one, make more sense. Yeah, so you can see here, for example, protein, fat, carbohydrates, calories. This is a daily requirement, say 2000. And I am, I think, a little bit excess there. And protein is not fully met. So you could see all the, if you want to draw in a more of a bar graph, like histogram, we can do that. So I am going to use an utility called terminal graph. You can download it or install through pip. To plot with term graph, the data has to be in this format, in a data file. So we could rewrite with open a data file, open say YouTube class, maybe data.date, write as f. We are going to say the first line, for example, for the term graph, it has to be something like this. So we say print at the rate, and so it has to be we say RDA and RDA comma y, maybe we call it as y value, I mean the value that we are having, and it has to be in file equal to f. So next, for maybe data, or yeah, in R, we say data, we need to print name is a comma separated variable, data name comma, then data of RDA, and then data of value, and this has to be separated by comma. So sep equal to comma and file equal to f. So this will write the data in the fashion that we want. And for example, we can look at the data, for example, more. We wrote something called yt class.data. So you see the data is like at the rate RDA, y value, protein and its value, and the RDA, the recommended daily allowance. So now we can just plot it. So I'm going to import OS. So we can say os.system, and we say we use term graph, and we know the file name was something called yt. The file name is this one. The file name, that is the file name, and we say in color, and we can say red and blue. So let us run it. So you see, so we get a bar plot, but say for example we have sodium, a protein. The thing is, it's not very well scaled because of the some of the values are in micrograms, and so we could maybe scale every value which is less than 100, 200, you know. So we can scale the values, just make scale the y values to 100. So we can say for I in R, or in R, we say if data of RDA not equal to 0, we say conversion factor, we can say. So 100 is the value what we want by data of RDA. And now we say, so data of RDA, it becomes equal to 100, say, and data of Y, data value becomes star equal to conversion factor. So everybody is getting scaled. Now let's see if you get a better, yeah, you can see a bit more clear. So everything has become 100 if it is not 0, and the other value is correspondingly scaled. For example, let us see the protein. Yeah, this is 100, so it's around 56. So it's not fully met. So we can see the areas. For example, I need to work, for example, things like protein, of definitely more protein, eat more protein, and you can tune in. Vitamin D is something to be 0, so you need to look into that. And and I think cholesterol is too high, the cholesterol, so those things I need to work on. And that is, and second thing we can do is that you can look at recommendation. You can create a pantry list. You see, there's a pantry list. Basically, we are going to create a recommendation. So first thing that you do is to create this pantry list and grab the data for all those items and the FTC numbers, and then grab the data and pass it on to the recommendation utility. So I'm going to show you. So we say we need a pantry list. So I have already saved it as a pickled form. So as a pickled item, so this is my fan. So basically you have to create that dictionary, grab the data, and go on using the same method that I showed before as like this get client.get foods. So you pass that dictionary, and so it will go and it will go through a loop because it will do 25 at a time. And now once you do that, I can use I can create a recommendation is equal to noms dot generate recommendations. So we need to pass in meal, pantry foods, and then noms dot nutrient dict. That is the data of the nutrition dictionary. Nutrient dict is basically the nutrition. There's all the RD values for 41 nutrition that's already saved in there, and 3 is how many recommendations do you want. So we do that, and now I can say for rec in recommendations. So we use we just print we use the recommendation second variable, which is how much food that how much grams of a certain food that you want, star, and we convert it into grams. We multiply the scaling factor of 100, and then if you want to round it, for example, round to 2 decimal places, and then you say in grams, and if you want grams of, if you want to say then, and the pantry foods gives the list that we created. We downloaded the whole data, and we use 1, basically that is the ID corresponding to that number, and that will pick up from the pantry foods object and use to describe which is that particular food. So pantry foods, not 1, he said recommendation 1. Yeah, So let us see. So we can see here that it recommends us. So that REC 1, 2, 3 says a list. So 0, 1 and 2. Second one gives us how much amount you need to consume, and you convert it into 100. That is 100 factor, and 1 represents which number in the pantry list, which is a number. That is the second entry, the index number 1. So we see, like, it could give me 3 recommendations here to make up the deficiency that we saw. So it says 15.45 grams of fish, from the pantry. So it's comparing the actual list, actual food that I consumed, and compare with the pantry food that we prepared, and it is recommending from that. So it's a really nice, beautiful package. I personally am using it to look at what are the deficiency that I have. And even if you're using for anything else, even if you just want to grab the data, it is amazing. You can grab the data and look at the nutrients and other stuff, and for some other purpose. I basically use it for look at for a personal nutrition analysis. Thank you for watching.